What's up, fellows? Let's continue with our planks. I'm going to do the retopology of the two missing ones. As I'm not going to do anything that I haven't done before, what I'm going to do is just a time lapse, just in case, so that you can see the whole process. But well, just know that it's exactly the same, okay? What I am going to do first is to duplicate the quad. For example, Shift D. I take it here and separate it with the P so that it is another object separately. As the shrink wrap is already configured, then I change the target with the E and click. And I can start working on this table. Okay, so let's go ahead with it. What's up, fellows? Let's continue. We had already done the retopology of the wooden boards, and well, let's do the rest. For the rest, it's quite simple because the pieces don't really have much mystery. I think we can even start from the bases we had. If you remember that in the blocking we had a series of pieces, I think these can be duplicated. Shift D. We are going to activate the shortcuts, and with the M we are going to move it to the low folder. I'm going to put low first, which is more comfortable for me. Low and high second. Then now I select it. See, I press Shift 2 to see the high folder, and if we go to edit, we will check what can be reused and what not. If the pieces do not have much breakage, well, most likely we will be able to take advantage of them 100%. Here in this case, maybe we have to give it a little more shape and so on. And if we see that there is a hole a little bigger or whatever, then we have to touch it, you see? Here this cannot be floating, etc. But well, it is not more than that. I am going to put the in front. I will activate the snap to faces. And let's give it a little more shape. If I see that I need geometry, I'll do it Alt D. We connect. Let's add a little bit of geometry here. Be careful with the n-gons. The polygons of 5 sides or more. And as we are doing it from a piece that is already made, I mean that we have started from another one and we create new vertices in the closed piece. It is possible that we generate some n-gons unintentionally, but well, nothing happens. Then we will pass the checker of n-gons and we will see where they are. I'm going to deactivate the in front of these pieces. There, no, they are still there. In front, and then in front so that it doesn't bother me when it comes time to retopologize this one. Here we still have to, I'm going to move a little bit, we have to make a hole and maybe we can't leave that hole back here. If it's just a little bit, you know that the normal ones work well and can be disguised, but if it's a lot, it's better not to do it there. I'm going to take advantage of these new cuts to add others around here. And these go down where the little hole is. Here. I'm going to dissolve this. Careful that it usually removes the vertex. There, and I want to keep it. No, I'm going to connect it up to here. There. There's a little bit of a step. And here. Careful so that this doesn't sink in here. Let's put it on the edge. And now we make an inset, for example, to make the descent. Here with the eye. And now we reposition it. A little bit lower. Well, you already know that if you want to keep this flat, loop tools flatten. And this is where we'll have to connect. We're going to create a support part here. Subdivide in this. We leave it there at 0. We zoom in and connect. If we connect from this one to this one, there might be too much tension, so it's better to bring another edge to it. Here I'm going to flatten the same thing. Loop tools flatten. There's no more of those tensions there. And here the same thing. I've got it on shortcut. Pressing Q, flatten. Let's finish this piece off at the corners. Here, there. Let's connect. And maybe up to here. I'm going to flatten this. Let's see if there are any n-gons. To do this with a mesh check add-on, I'll leave you the link. We activate it and say that we want to see the X-ray to see it through, and we want to see the n-gons. As you can see, there are red giant n-gons. Let's connect them. One less. If you want to disable the X-ray, it's just to see them through. But since we're doing retopology, I think it's good for us. Otherwise, the high poly piece is going to bother us. I think it's better from here to here. That's it. And we'll take this off. I think that's it. Maybe we can even connect here. This one with this one. This one we remove. This one we take off. We connect here and it will be a little bit cleaner. That's perfect. Well, you got n-gons. I'm going to save a next piece. These should be pretty easy because they almost match us. I actually think I could leave this piece as is. There would be no major problem. Let's see this one. Well, this one would need a little bit of tweaking. I'm going to deactivate the add-on. Then I'll activate it when I go to correct. We are going to put in front. We're going to fix the corners, which is where we've added the most wear and tear. I'm going to connect this one to here. This one here. I'm going to dissolve this. And these are just like Alt-D. I almost better connect here. So in this corner, I think is the last one I'm missing. And now we connect this one with this one. Here's another Ngon. I'm going to activate the add-on. Let's see. Here we are going to generate a new one. Oops, here we run out of geometry. Let's disable the add-on and check that. Let's connect. See, we can't leave these geometry holes because the delta goes over here and that's not the plan. Let's add extra geometry there. Here it is too. This one we connect. And this, so as not to generate an Ngon, we'll connect it there. The same thing can happen here. I'm going to connect there. This hole is tiny. I'm not too worried about it. Okay, let's activate the add-on. We connect with the M. This I can remove. This one here I connect it. This one with this one. And this one to this one. I'm going to take it up to here at last. I think that's it. Finally, except for the next piece. This one is simple. What I'm going to do is add a little more geometry. Control 1. With the subdivision surface modifier, I'm going to apply it. Control A. And now we start with a geometry with more density. What happens is that it puts density also where we don't need it. For example, here maybe it puts too much density. I'm going to dissolve this one. I'm going to dissolve here. All this in the back can be simplified. I'm going to go here to the F. I'm going to make an insert with the I. I think I can delete this one. And I'm going to start connecting here with the F. And that's it. And now it will be necessary to move it with the snap so that it sticks to the surface. And the same here. What I do is I go to faces mode. I select in the middle to select the 4 faces. And now with Ctrl plus the selection to add, because we are going to go adding a grow for the F insert. I erase with the X and connect with the F. And I think we can add a shrink wrap. And it will be easier than moving it vertex by vertex. I'm going to add it with the speed retopo. Click on add shrink wrap. And I just have to choose the target here with the E and pick the high model. And we'll have it there. Now, if I need to add a little bit of offset, something like that, and it will be more or less square than... If we do it by hand, it can be the same, but it will take longer. Now, simply taking advantage that we have the modifier, we are going to reposition what is missing to make it look good.
And this way, do GG. And here the same. I deactivate snap and GG. Bring it more to the edge, and now whatever is needed is repositioned. If the shrink wrap gives us a lot of jumps, you know that now we can update it. It will apply it and put it back. And now you see it doesn't make those little jumps. That's because the geometry wasn't really close. The original one was very displaced and it had to be calculating every time we moved. Once we have it, we can apply the modifier. That we apply the modifier, and we would already have all the pieces of the retopology of our pieces. In the next class, we will see the UVs. Greetings.
What's up, fellows? Well, let's move on to the UVs part of our models. We are going to deactivate hyperly for a moment. We only want to see the low. And to add the UVs, the first thing we are going to do is to assign first of all a checker material. If we still have some pieces, as I am seeing, with modifiers, I can easily see them there. So let's apply them. We had these 3 tables with shrink wrap. I'm going to apply it, Ctrl A. And in the case of those that we also have a solidify, to see the retopology better, we deactivate the solidify and apply the shrink wrap with Ctrl A. I think the others are correct, well, except, and let's go to it. Let's go to shading. Here we're going to add a new material. A material, I'm going to call it checker. And we're going to do Shift A, we're going to search, and I'm going to search here for checker texture. We'll hit. And now we simply connect the checker texture to the base color. We can pull like this, or we can select both nodes and hit F. And now let's see. Here we have the checker. This will help us to see if the texture is distorting, if it is all square, as it seems to be the case, almost completely. It means that our distortion will be very little and will be fine. And if we see that a square is no longer square, it means that it is distorting a lot and we will have to correct it. To see it well at all, because right now what we are seeing is not the UVs of the object, but a mapping that Blender does automatically. That's why we see it too. So to add the UVs to the checker, we have to add a node here. Shift A and put UVs map. Connect it with the F and tell it to use our UVs map. As you can see now, it is much worse, so it is important to add this material when we are doing unwrap. I'm going to select everything with the A. As you can see, this one has been active. The good thing is that having this active, we can do Ctrl L and assign to all the same material, and so everyone has the checker. The checker itself is very large. It has a size of 5, a repetition of 5. Let's put 50 so that we can see smaller squares. And now we can go to UV editing and start mapping. We'll have to turn viewport shading back on here. The viewport shading to see the checker texture. Oh, and if they are not seen as is the case of the tables is because the mapping is very, very bad, but it is normal. We have not even started to map. Let's start mapping. I'm going to start with the tables. What we're going to do is we're going to add slices so that this can be displayed properly. Right now it's all kind of concentrated down here in 1 pixel. It doesn't have any mapping per se. If we were to hit the U and make an unwrap by default, it could not be opened because there is no cut. It is a closed piece. So what we have to do is to give it cuts so that it can be unfolded. Well, to do that, I'm going to give it a cut in the back here. which I think is the part that is going to be less visible. Although it is true that we can turn the boards around, that's the idea too. But we have to cut somewhere, and I think that this is where it is going to be less noticeable. I'm doing the little path with the K drill. Let's see, a little less. No, not this way, and we go up. That's it. And now with Ctrl E, or in the edge of the right button, mark seam, we will have marked a red line that indicates where we are going to make the UVs cut. And if now I select again everything, and the U and I do unwrap, we will have our board unstretched, and as you can see, the tension seems to be quite good. I go to some point where it is a little more tense, as here. You see that the square is stretched a lot. In such cases, it would be necessary to see how to untension here. One of the solutions is usually to break here so that the tension is less. For example, I select these two edges, Ctrl E, and make a mark seam directly in the UV viewer. Mark seam. Recalculate the UVs and now this part, well, that must have gone somewhere else because this is recalculated. It's a little bit less tense. Taking advantage of the fact that we have here a quite interesting area to explain something about the UVs, is that when we are doing UVs, as you can see, these little boxes look one way. By how our geometry is triangulated. If we were to change the triangulation, right now Blender I think is doing this internal triangulation. No, not this one, because you see it's changing this one. Blender is doing this internal triangulation, but it's possible that other software triangulates in another direction. You always, when you take from Blender to other 3D geometry software, especially to video game engines, that software will most likely triangulate. And what direction will triangulate? Well, each software triangulates in its own way. Then, in Blender, it triangulates like this, but in other software, it may triangulate like this. And as you can see, it moves. The little boxes behind the texture move. Well, that same thing will happen if we have the Blender triangulation. And we send this, for example, to Substance Painter. That will almost certainly triangulate in another direction. Then we must take into account if you see this type of distortions, it is because of the triangulation. Then the most interesting thing is to export the triangulated model. We will see that when we finish all our UVs. I'm going to see how it was. I'm going to delete this tension sim. I'm going to recalculate, and now we'll try to fix it. And I'm going to continue with the next table, so we don't spend too much time per table. And then we'll do an array pass. Next table the same. Antidiente. Here I see that I should not have finished the topology. I have been left with a hole. It is very normal to find when you do UVs many little failures. In fact, it is quite good, because many of the failures that we can have modeled here, as we have to go more calmly and look at everything well, because we will see it right away. I do not know if I have not done it, or simply I have been erased without wanting. I will fill it with the F. Let's see this. I can't connect it anywhere there. And this one here, and I think it is 1, 2, 3, 4, 1, 2, 3, 4. There's no on 1, 2, 3, 4. Well, so let's go on with our UVs. Let's see where we cut. Well, I think maybe this way at the back. Careful. This is going too far forward. I think we have to go this other way. Better. Okay, and once we have it, mark seam and the U unwrap. And we would have the following table. And let's go down this other one. Let's go down. Let's go around. Maybe we can squeeze more down there. Oops, we went a little bit too far earlier. It all depends on the topology of the wood, of course. And we can do... sometimes I'll even do a mark seam so I don't lose what I'm carrying. Sometimes we can force triangulation here just to make better UVs. For example, here the same. We can say, well, we connect here and do the UVs over there. Nothing is going to happen. Okay, we deployed to the unwrap U. Okay, perfect. Next piece here, we are going to apply the same criteria. We are going to cut from behind. We are going to cut from the back. It should be relatively simple, this piece. A little bit more this way there. Up to here, mark seam. Let's deploy. Okay, here maybe there's a lot of tension, you see? This piece here has a lot of tension in it. What we're going to do is cut it right over here. Mark seam in this way. Mark seam, we deploy. Okay. Maybe we can even cut this seam here in the back and join it to the back. Let's see how it looks. Clear seam, unwrap. Oh, well, we've simply prolonged it so that it continues over there and over here. It could be an option. Let's leave it at that for the moment. I'm going to save. I'm going to call UVs. And let's go to the next piece. This one here, which is very simple. Okay. I think we can cut through here quietly, mark seam. Okay, let's unfold and there we would have it. Perfect. Next piece. This is also very easy. I think we can cut here, mark seam. Let's test how this unfolds. Terrible because we have to add another cut. For example, a lateral one. Mark seam, and there we have it. And this last one is also very easy. No, we cut here in the back. We are going to add these cuts so that we can do it. Let's see, there, here. Mark seam and unwrap. Okay, since there's a lot of tension here. So we're going to have to cut. We're going to cut here as well. Okay, we're still having the same problem. We're going to make a lateral cut. And this is a little bit better, and I think we would have everything. Let's select all of them. Here also with the A, and we go to UVs and select average island scale. What this is going to do is to put, as you see, all the islands to the correct size. That is to say, their real size. So that this little box here, this checker, and this, and this, and this match. Because otherwise, it could happen that if we scale this is bigger or smaller. What does this mean? Well, that right now, this object would have less resolution because it has a bigger pixel. And on the contrary, if you make it bigger, it has more resolution because it has the smallest pixel. So that there are no differences between pixel sizes, that a piece does not have better resolution than another because it will look weird or worse. Then you have to match everything with average island scale. In the next class, we will talk about the textile density, which is basically what I am telling you about now. Oh, but to think about it for all the other objects we're going to make, okay? So nothing will save. See you in the next class. Cheers.
What's up, fellows? We are going to continue with our UVs deployment. We had them already open. Now we have to do the packaging. You open. Now we have to do the packing, and we are going to see if all this fits in the texture size that we want with the texel density that we are looking for. Okay, first of all, make sure that whenever we deploy UVs, we have the scale of the objects in 1. This is very important. If for whatever reason this scale is moved, it will display us according to the size of the object. So it's important to Alt Ctrl A, apply rotation and scale before you unfold. I'm going to go back to unfold, unwrap, and there we're going to have everything sized correctly. What are we going to do now? Well, next we are going to see how well these UVs are displayed. We are going to go to the Overlays tab in the UVs, and we are going to activate the stretch. With this, we will be able to see the stretch of each texture. In this case, by angle, you can set by angle or by area to see how much texture size is occupying our object, if it is correct or not. But what interests us above all is the angle that is going to be the distortion, which is a bit what we were seeing here. When we are doing unwraps, there are 2 ways to do it. One is to simply hit the U and unwrap. But if we look at in the unwrap options, we have 2 methods. One is based on the angle and one is conformal. The conformal is usually used mainly in hard surfaces, things especially that are not organic. Then I would take a look at all the pieces that we have of this type. It means this metal piece, this other one that is quite square, unwrap by conformal. In some cases it will go well, in others not. For example, in this piece it seems that it goes worse, so we unwrap by angle. Anyway, I already told you that we will probably leave this piece straight. Why are we going to leave it straight? Because it is more difficult to fit this piece in a puzzle. Imagine a Tetris with round pieces than a Tetris with square pieces, because it will be easier to pack everything with square things. Because in this type of pieces, what is usually done is to leave the piece straight. It is not something that can be done in all. Also keep in mind that we will distort a little more, but it is compensated on the other hand because we will be able to pack better. Then that is a little balance that must be maintained. In this case, we are going to do it. There are 2 ways to do it. The first one would be from within Blender itself with an option in right button that is called Follow Active Quads. But if I give it right now, it is going to do something very strange. What we have to do before giving Follow Active Quads is to put straight all the edges. So I select one, we can give it a line auto. Here Shift R to repeat, Shift R, Shift R. I'm going to select everything, and I'm going to make sure that this is the last one that I select with the Shift. That is the active quad. And now follow active quads. Now we would have our piece unfolded perfectly straight. Do we have a little bit of distortion? Yes, but you know that at least the packaging will be a little better. So one thing for the other. Another way to do it is with the UV squares add-on. That has directly a button to do this, or with Alt E, that would be the shortcut to put straight of this add-on of UV squares. That if you want, I will share it with you, and if not, you will have to put by hand straight a face, and all will follow that face, okay? What else? Finally, this was already there, and we are going to see now something very important. It is the packaging. I'm going to give a little bit to UVs, average island scale, so that they all have the same size, although this is going to be a bit of a problem, because now we are going to choose the texel density. What is the texel density? It is the density of pixels per meter. In environments, it is very important in games to have a coherence of texture size between objects. I mean that if we have an object with a lot of resolution next to another one that has less resolution or low resolution, it will be very noticeable. In characters, this does not usually happen so much because the characters themselves go with much more resolution, but in the scenarios we must always try and as far as possible to maintain the texel density. How are we going to calculate the textile density, and what textile density do we need? This depends a lot on the platform where we are going to make the game. For example, if it is PC, then surely we can have more resolution. But if, for example, we are going to move our game from PC to Switch or to a console with less memory, because this especially affects the textures, then we will have to be more careful with the textile density. My advice is to always try to have a textile density that is easily scalable down, so that if we are suddenly asked to lower the resolution of all the textures, it is easy. We are going to do the example with the textile density add-on, which is an add-on that I will share with you. It is very, very good, where we can configure our textile density. The first thing is to choose the texture size. We are going to choose that our texture is going to go in a map of 2048, which is kind of the standard nowadays, 1024, 2048. It can be the average of the textures. Then we are going to choose here a checker material. We are going to give it to assign checker material so that it puts us its own checker, and then we are going to choose here the textile density we want. What does 5, 12, 10, 24, 20, 48 mean? Well, it is 64 by 64, 128 by 128, 256 by 256, 512 by 512, 1024, and 2048 by meter. If I now click 512, or at 5112 per meter, as you can see, the size has changed. In fact, I'm going to do it with the textures here so you can see it. As you can see, it is setting the size of the texture to each meter being 512. So if all our game has this textile density 5.12, we will get everything to be uniform in resolution. This is a little more tedious, but well, I want you to understand the general idea. That is that the scenarios are always seen with the same texture resolution or as close as possible. It is not a super strict rule. In fact, there are games that skip it a little more to the whim, others less. It depends a little on the study, but in general we must try that everything has the same resolution. Once we have set our texture to 512, which is a size, quite moderate size, we are going to try to pack this textile density in 2048. For this, we are going to use the UV Packmaster add-on. It is an add-on that I will also share with you. You know that from Lootbox you have all these add-ons, and here we are interested in, of all the options that it brings, we are interested in activating the following. Let's see a little above what we have here. Let's fold everything to see them from scratch. The first one here is an overlap check to see if there is overlap. Right now there are pieces on top of each other, so there is overlap. The measure area will tell us how much percentage of texture we are using. The higher the better. Now we will see it. Validate UVs in case there is an error, and pack is packing, which is what we usually give it all the time, but we have to configure this a little more. From packing device we can choose the CPU or the GPU to do the calculations. It doesn't matter a little bit. Surely if you have an NVIDIA GPU you can load it there so that it does it a little bit better. And in basic options, because if you have put by CPU how many cores you want to use of your micro, and the precision, I think the precision usually comes in 200 by default, or I usually raise it to 500, but try not to overdo it. If not, we are going to mess up the program a little. Rotation enable is that the pieces can rotate when we click pack. If we remove it, then we will keep the rotation they have at that moment. Surely we want them to rotate unless it is a very specific case, but generally it is usually believed that they rotate to look for a better puzzle. What else? Of the advanced options, we will not have to touch anything now because we are going to make a single texture. Pixel margin, this is also important. Here we are going to touch the margin between islands, the pixels between islands. There is a table in Polygon, that is the one that I recommend to see okay. It's called edge padding. I have passed you the link, and if not, well, here you have the easy to find address. That you can see what happens to the islands when you change the min mapping of the texture. That's because when you're watching a texture in a game, the more you move away to get more memory, and because you are not going to use a very large texture for a small object, the smaller the textures become, so the size of the pixel grows. I think I have explained it a little bit before, so in this guide. Well, first you can see what happens when you go from 512 to 256. 128, the pixels will get bigger and start to encroach on each other. So that this does not happen, you have to leave a space between the islands. This space has like tables that more or less work well. So here we have the table. If we make a texture of 5 on 12, we must leave a space of 4. And we make one of 1024 of 8. And if we make one of 2048 of 16 pixels, that is the margin for sure. You can squeeze a little more, a little less. If you can put a little more, a little less. But well, the ideal is to try to have this margin. So what are we going to do? We are going to put 16 as soon as we add the pixel margin here, and let us touch the size of the texture. Then we are going to take advantage of it, and we are going to say that our texture is of 2048. Okay, what is the padding? Because you will see, the margin is the space between islands, and the padding is the border between the island and the border. I mean, when an island is here in the border, and here there is another island this distance from here, is the margin, and this distance from here is the padding. Then in the padding we are always going to put half because we want to reach 16, but of course they are half here, and think that this is repeated down here and the other half here, so we have to put half by putting 8 in this case to make the 16 half down and half up, because we would already have it. That more heuristics, we have to activate the heuristics, because to make better calculations and the advanced heuristics, and this we are going to leave to 0, so that it takes the only one that we have to look for is the fixed scale, so that it does not change the size of our islands, because if we remove it, it is going to look for the best size. In fact, we are going to make a test deactivating it. We are going to select everything. We are going to give it to pack. You can add these favorites, I have it here, and hit pack. It will be able to calculate until you hit ESC. It won't stop. But right now it is doing 78% of the island. Look, it is 79.2%. The higher the percentage, the more you will be taking advantage of your texture. That is what happens, that this is very good for characters. But when we are doing scenery, we can't do this. We need to be inside a texel density. I'm going to cancel it with ESC here. They have packaged it very well, but it's not worth it. Because if we go now to the texel density add-on and ask him to calculate the texel density, it tells us that we have a texel density of 4.7. So we have gone down from 5.12 to 4.7. This change is too abrupt. I mean that if we then put another object that has the texel density of 5.12, we will have a hard time, because these textures will look a little worse than the ones we have already seen. What do we do in these cases? We activate the fixed scale and click on 5.12. For this to be the texel density, which is what happens now, that if I package, well, no, it is not going to enter us. As you see, it does not fit us. And as it does not fit us, the texture, that is what we can do well, because here it enters in factor many things we can try if we see that it is possible to improve a little the UVs of our object, so that they occupy less. But I believe that right now they are already well enough packaged and well enough deployed that removing a little bit or making some pieces straight will gain a lot of resolution. For example, you can make a piece that will never be seen or will always be in shadow, a little smaller, even if it loses textile density, but it will never be seen, nothing happens, and we can pack better. But it is not the case because these pieces are for a modular asset that can be looking in any direction. So here come the sacrifices that we can sacrifice, because I think that in this case we can sacrifice one of the 3 tables. For example, I will select only these 2. And let's see how much it packs. Now let's select all of them, let's pack. I'm going to make sure it's at 512, okay, perfect pack. Well, now you are packing with this textile density, and it is not going to move from that textile density. Now, what's the matter now? That we have plenty of room, I will click ESC, and we have plenty of this. What can we do with all that? Well, there are several options. One of them could be to make a trim sheet out of some material we need, such as rope or something like that. It would be a good option. Or metal, I think that's better to see it in a tutorial a little more advanced. And what we can do is break a plank. I am always thinking of things that are useful to us. To have one of these planks like this, something like this would be to take all of this off. And then to split a plank as if it were chipped. That can be useful for when we are doing the composition of objects, because having a split table today can always be good. With this configuration it would fit us. Let's see it. We are going to pack. It would fit us better. The truth is that here there is still a gap. We could tighten it a little bit more, but I think it would fit us better. Here we could do one thing that would be to scale a little bit, but very little. I'm going to do it with the shift upwards a little bit, the textile density, and repack to make good use of the texture. It might work, it might not. Depending on how well it does the packaging, the add-on seems to do it. There is a bit of overlap here. They are not stepping on it, so maybe we will not be able to get back to 5 DOS. Voila, here then it is that we have to sacrifice things. In this case, this board, or the one I like the least. I will choose the one I think is the ugliest, and I'm going to split it, and that's it. You have to go back to ZBrush and touch if you have to go back, but nothing happens. This is the work of environment. It's a bit like I was telling you that you had to prepare the files always to be able to go back, because it is very common that in environment, because you have to go back, or if we had been short, in terms that we had a lot of resolution left over, because imagine that instead of a texture, we do it in 2, well, that would be another option, and it will pack in 512, only this is worth packing there. What's wrong with us that we have too much of it? Here you can say, okay, I'll add one more and repackage it. Okay, I have less left over. And now I'm going to add this other one and repack it again. I have less space left, and so on, adding pieces to complete the texture sheet if obviously this table does not fit because it is too big. You see that this does not fit. What you can do is to take this table out in another texture along with other objects like this one plus this one, and go slowly as making 2 textures and adding objects, but we would have to go adding objects then. As I think it is not the idea to add more objects, we will select the table that we like the least and fix it to enter textile all in one texture. Okay, I hope that more or less is clarified how the textile density works anyway. Any questions, ask me, and nothing. See you in the next video. Greetings.